Cloud adoption is now a certain part of the technology transformation that the world is undergoing, be it fintech born in the cloud companies, traditional enterprises adopting digital transformation, or manufacturing firms implementing industrial Internet of Things. Cloud computing is everywhere. Where once companies used to refrain from adopting the cloud due to data ownership and security concerns, today leaders are beginning to challenge CIOs to speed up cloud adoption. Cloud computing and storage delivers users with the ability to store and process their data in third-party data centers such as AWS, Azure of Google Cloud Platform. Organizations use the cloud in a variety of different service models: software as a service, platform as a service, or infrastructure as a service, and in a variety of different deployment models: private, public, hybrid, and community. Security concerns associated with cloud adoption fall into two broad categories: security issues faced by cloud providers, organizations providing software, platform, or infrastructure as a service via the cloud, and security issues faced by their customers, companies, or organizations who host applications or store data on the cloud. Therefore, security of cloud environments is a shared responsibility. The provider must ensure that their infrastructure is secure and that their clients' data and applications are protected, while the user must take measures to fortify their application and use strong passwords and authentication measures. Some of the key security challenges that CISOs are facing as they seek to enable businesses to adapt to the cloud are ensuring businesses adopt cloud computing in a controlled fashion without the CISO becoming a bottleneck to technology transformation, ensuring the contractual framework with the cloud service provider is in line with industry, regulations, and laws of the land, ensuring secure data transfer between the on-premises infrastructure and the cloud, ensuring secure connectivity between private and public clouds, ensuring appropriate governance and oversight mechanisms over cloud service providers, ensuring that the security features of the cloud service providers such as AWS and Azure are properly understood and implemented, managing identities across complex environment, identifying assets and vulnerabilities in hybrid environments, addressing the challenges of DevOps, no traditional security segregation between environments, dynamically changing production environments, container security, infrastructure as a code, etc. Ensuring as far as possible that the cloud computing environment meets or exceeds the security posture of the organization.
Magnitudes of cloud security. It is generally recommended that information security controls be selected and implemented according and in proportion to the risks, typically by assessing the threats, vulnerabilities, and impacts. Cloud security concerns can be grouped in various ways: identity management, physical security, personnel security, privacy, cloud vulnerability, and penetration testing. Identity management. Every enterprise will have its own identity management system to control access to information and computing resources. Cloud providers either integrate the customer's identity management system into their own infrastructure using federation or SSO technology, a biometric-based identification system, or provide an identity management system of their own. Physical security. Cloud service providers physically secure the IT hardware, servers, routers, cables, against unauthorized access, interference, theft, fires, floods, and the like, and ensure that essential supplies, such as electricity, are sufficiently robust to minimize the possibility of disruption. This is normally achieved by serving cloud applications from world-class, i.e. professionally specified, designed, constructed, managed, monitored, and maintained data centers. Personnel security. Various information security concerns relating to the IT and other professionals associated with cloud services are typically handled through pre-, para-, and post-employment activities, such as security screening potential recruits, security awareness, and training programs, proactively. Privacy. Providers ensure that all critical data, credit cards, for example, are masked or encrypted and that only authorized users have access to data in its entirety. Moreover, digital identities and credentials must be protected, as should any data that the provider collects or produces about customer activity in the cloud. Cloud vulnerability and penetration testing. Scanning the cloud from the inside and out is imperative. Virtual servers should be hardened like a physical server against data leakage, malware, and exploited vulnerabilities.
Data security. A number of security threats are associated with cloud data services, not only traditional security threats such as network eavesdropping, illegal invasion, and denial of service attacks, but also specific cloud computing threats such as side channel attacks, virtualization vulnerabilities, and abuse of cloud services. The following security requirements limit those threats. Confidentiality. Data confidentiality is the property that data contents are not made available or disclosed to illegal users. Outsourced data is stored in a cloud and out of the owner's direct control. Only authorized users can access the sensitive data, while others, including CSPs, should not gain any information of the data. Meanwhile, data owners expect to fully utilize cloud data services, example, data search, data computation, and data sharing, without the leakage of the data contents to CSPs or other adversaries. Access controllability. Access controllability means that a data owner can perform the selective restriction of access to their data outsourced to the cloud. Legal users can be authorized by the owner to access the data, while others cannot access it without permissions. Further, it is desirable to enforce fine-grained access control to outsourced data, i.e., different users should be granted different access privileges with regard to different data pieces. The access authorization must be controlled only by the owner in trusted cloud environments. Integrity. Data integrity demands maintaining and assuring the accuracy and completeness of data. A data owner always expects that her or his data in a cloud can be stored correctly and in a trustworthy manner. It means that the data should not be illegally tampered, improperly modified, deliberately deleted, or maliciously fabricated. If any undesirable operations corrupt or delete the data, the owner should be able to detect the corruption or loss. Further, when a portion of the outsourced data is corrupted or lost, it can still be retrieved by the data users. Encryption. Some advanced encryption algorithms which have been applied into cloud computing increase the protection of privacy. Compliance. Numerous laws and regulations pertain to the storage and use of data. In the U.S., these include privacy and data protection laws, payment card industry data security standard or PCI DSS, the Health Insurance Portability and Accountability Act or HIPAA, the Sarbanes-Oxley Act, the Federal Information Security Management Act of 2002 or FISMA, and the Children's Online Privacy Protection Act of 1998, among others. Similar laws may apply in different legal jurisdictions and may differ quite markedly from those enforced in the U.S. Cloud service users may often need to be aware of the legal and regulatory differences between the jurisdictions. For example, data stored by a cloud service provider may be located in, say, Singapore and mirrored in the U.S. Many of these regulations mandate particular controls such as strong access controls and audit trails and require regular reporting. Cloud customers must ensure that their cloud providers adequately fulfill such requirements as appropriate, enabling them to comply with their obligations since to a large extent they remained accountable.
Business continuity and data recovery. Cloud providers have business continuity and data recovery plans in place to ensure that service can be maintained in case of a disaster or an emergency and that any data loss will be recovered. These plans may be shared with and reviewed by their customers, ideally dovetailing with the customer's own continuity arrangements. Joint continuity exercises may be appropriate, simulating a major internet or electricity supply failure, for instance. Log and audit trail. In addition to producing logs and audit trails, Cloud providers work with their customers to ensure that these logs and audit trails are properly secured, maintained for as long as the customer requires, and are accessible for the purposes of forensic investigation, for example, e-discovery. Unique compliance requirements. In addition to the requirements to which customers are subject, the data centers used by cloud providers may also be subject to compliance requirements. Using a cloud service provider can lead to additional security concerns around data jurisdiction, since customer or tenant data may not remain on the same system, or in the same data center, or even within the same provider's cloud.
The European Union's GDPR regulation has introduced new compliance requirements for customer data. Ampcus Cyber and their team of experts follow the Cloud Security Alliance Control Matrix. The Cloud Security Alliance Cloud Controls Matrix, or CCM, is specifically designed to provide fundamental security principles to guide cloud vendors and to assist prospective cloud customers in assessing the overall security risk of a cloud provider. The CSA-CCM provides a controls framework that gives detailed understanding of security concepts and principles that are aligned to the Cloud Security Alliance guidance in 13 domains. The foundations of the Cloud Security Alliance Controls Matrix rest on its customized relationship to other industry-accepted security standards, regulations, and controls frameworks such as the ISO 27001, 27002, Ithaca COBIT, PCI, NIST, Jericho Forum, NERC SIP, and will augment or provide internal control direction for service organization control report attestations provided by cloud providers. Application and interface security, audit assurance and compliance, business continuity management and op resilience, change control and configuration management, data security and information lifecycle management, data center security, encryption and key management, governance and risk management, human resources security, identity and access management, interoperability and portability, security, incident management, e-disk and cloud forensics, supply chain management, transparency and accountability, infrastructure and virtualization, mobile security, threat and vulnerability management.